Before we begin going over the review problems for Unit 3, Chapter 4, there's a lot of terminology in this unit that we need to really kind of brush over first before we get into those questions. So let's do that real quick. You can find these in the summary sections of all of your sections in Chapter 4. So we'll talk about census, that's collecting every data from the population. A sample survey selects a sample from the population of all individuals from which we desire information. We want to draw conclusions about the population. Convenience sampling chooses individuals who are easiest to reach. Voluntary response sampling, individuals choose to join the sample in the response to an open invitation. These are going to lead to bias. They're not really good sampling methods. So you'll see voluntary response and convenience sampling as a very last resort. They're likely going to underestimate or overestimate values. Random sampling is using a chance process to select example, and those are always preferred. And so we're going to study a few of those. So random sampling is always what you want to try to achieve. Within random sampling, you have a simple random sample. That's when every possible sample of a given size has the same chance to be chosen. You want to make sure you're sampling without replacement when you're doing that. That's important for independence purposes. Yikes. A stratified random sample is when you have different strata. You divide the population for groups that are similar, so homogeneous groups like grade levels or whatever, and then you sample within those different strata. So stratified sample, you sample within those strata, then you combine the simple random samples of each strata together, and you have one larger sample that's more representative. So those are good. Those are representative. We like those, representative. We also have another representative sample called a cluster sampling, but cluster sampling does have more variability in it because what happens is you randomly sample different groups of the population. The groups are heterogeneous, not homogeneous. So what you want to do is you do like city populations, you do zip codes or something, and they might have heterogeneous in there, and you want to sample within those zip codes or whatever. So you randomly sample different areas, and you randomly select different areas, then you sample everybody within those groups, and then you combine your results. And finally, systematic is like you have a certain periodic response. So like every fifth person, you're going to sample on a list of in a roster, let's say for instance, where you want to spread them out. So it's going to be easier to conduct when you have like things in order or listed, and you do a certain value every time. So those are the four main types of sampling. Then we have bias with random sampling can occur if you are undercovering. So if you don't have some members of the population likely to be chosen. And then non-response is a different bias when people just can't contact or can't be contacted or refuse to answer. And then you can have response bias where you have poorly worded questions that lead to answers that give you bias. So that's all about sampling. 4.2 covered different experiments. So let's go over those real quick. An experiment. The goal of an experiment is to make comparisons and see if something worked. So you have an explanatory variable, that's your independent. We want to see if something changed or causes another. So the experiments try to determine cause, and the response variable will measure that. There's confounding when the effects of responsibility can't be distinguished from each other. So it could be something else that confounds an experiment. There's a difference between observational studies and experiments. Observational studies examine existing data, whereas experiments try to do something to people, animals, or objects, or whatever, to see if effect and cause is shown to give us some new data. So retrospective versus prospective. Retrospective is using past responses to see what's going on with the data. And prospective is you're tracking individuals into the future to see if something occurred from their data. Experience, we have treatments. Treatments are sometimes they're imposed on experimental units, which we often call subjects, a lot of times if they're people. Each treatment has a combination of the levels of the explanatory variables, also called factors. So usually we see subjects, factors, and treatments when we're talking about those. A placebo is used to basically help control the group. We want to prevent confounding due to the placebo effect, because taking a medicine, you might think that you are being treated when in actuality you aren't. So we have to offset that with placebos. Blind versus single blind, double blind. Double blind is when the experimenter and the person being experimented on don't know what treatment they're getting, and single blind is only when one group doesn't know what the experiment is doing. Also, for experimental design, we have 4 basic features. Comparison, we want to compare at least 2 groups. Randomly assignment allows us to create roughly equivalent groups. Therefore, we can have a better comparison. Control is trying to help avoid confounding. So we can, with lots of measures we can do to implement control. And replication is we want to be able to have enough data to be able to tell if there's a significant difference in what the treatment is doing. A completely randomized design is your basic experiment. Think of that like a simple random sample in terms of sampling. Basically, every group has been randomly assigned, randomly chosen. There is no say in who goes where. A randomized block design is when you block people based off of different characteristics that might cause confounding, like gender or height or whatever. Blocks are chosen wisely. It's easy to determine if one treatment is more effective than the other. So blocking is effective. A matched pairs is a type of blocking where you're oftentimes comparing one subject doing 2 different treatments and getting the difference between those 2. That's a matched pairs design. And then finally, we can use inference to make we can use random assignment and random selection to determine if sort of inference about a population or cause and effect. So if you have random assignments, then you can infer inference about cause and effect. But if you have random selection, then you can also infer inference about a population. If you select from a population, you can infer about that. So if you have random selection, you can infer inference about a population, but you can't infer cause and effect if there is no random assignment. If there is random assignment, you can infer cause and effect, but if you don't randomly select, can't infer about the population. And finally, if you got neither, you can't make inference. So random assignment and random selection are ideal to infer cause and effect and to infer inferences about a larger population in general. So now let's look at this scenario. We're going to read the article. We're going to see if the researchers randomly assigned the pregnant women to consume or not consume chocolate during pregnancy. So let's look at the article. Chocolate consumption is associated with favorable levels of blood pressure and other cardiovascular disease risk markers. We analyze a prospective cohort study to determine whether regular chocolate intake during pregnancy is associated with reduced risks of preeclampsia and gestational hypertension. Here are the methods. Subjects were recruited from 13 prenatal care practices in Connecticut. Between these dates, in-person interviews were administered at less than 16 weeks gestation to ascertain risk factors for adverse pregnancy outcomes. Hospital delivery and prenatal records were abstracted to classify preeclampsia. This is the number in the experiment. And normotensive pregnancies. Chocolate consumption servings per week during the 1st and 3rd trimesters were ascertained at initial interview and immediately postpartum, retrospectively. Consumers of less than 1 serving per week comprised the reference group. Adjusted odds ratios were estimated by the use of logistic regression. We don't have to know all that, but from that data, we can get a few things. First, chocolate intake was more frequent among normotensive than preeclamptic or GH women, and associated with reduced odds of preeclampsia. Only first trimester intake was associated with reduced odds. Conclusions. These findings provide additional evidence of the benefits of chocolate. Prospective studies are needed to confirm and delineate prospective effects on chocolate intake of risks of preeclampsia. A lot of information on here, but here's the takeaway. Did the researchers randomly assign the pregnant women? The answer is no. They used data reported by the women. If you look back over here, you can see they were recruited from 13 prenatal care practices in Connecticut. In-person interviews were administered. Interviews, that's reported. So they were not randomly assigned. Was this an observational study or experiment? Well, it was an observational study. There wasn't a random assignment. There were no treatments imposed. They were simply asking women about their chocolate intake and reporting the results. What is the explanatory variable? Explanatory variable is chocolate intake. That's the independent variable. What's the response variable? Response variable is odds of preeclampsia and odds of gestational hypertension. That's the dependent variable. So does chocolate intake decrease the odds of these two things? And that was what we were trying to measure. Was this a prospective or retrospective? It says it was a prospective. It follows women's, so basically it asks women before they gave, let me read that real quick. It was prospective because it asks women less than 16 weeks gestation about this information about their chocolate intake. And then it measured stuff later on. So it was prospective. Uses old data if it's retrospective. This question, should Mrs. Pendleton eat lots of chocolate over winter break to lower her chances of developing preeclampsia? Why or why not? Sure, she can if she wants, but this data doesn't necessarily mean chocolate's going to lower her chances of it because correlation does not imply causation. That's an important thing. So you can have data support whatever you want, but you need an experiment to really determine if something actually causes it. And this was not an experiment. So we can't really say for sure if it's going to lower our chances. So I would say eat chocolate if you want. Doesn't hurt you, but always in moderation. Okay, 5, watch the clip from John Oliver's Scientific Studies. I'm gonna go ahead and play this for you. What does he mean when he says there was no control group? So we're gonna watch the 6:55.
Scientists themselves know not to attach too much significance to individual studies until they're placed in the much larger context of all the work taking place in that field. But too often, a small study with nuanced, tentative findings gets blown out of all proportion when it's presented to us, the lay public. Sometimes that happens when a scientific body puts out a press release summarising the study for a wider audience. For instance, earlier this year, a medical society hosted a conference at which a paper was presented comparing the effects of high and low flavanol chocolate during pregnancy. If that sounds narrow and technical, it was supposed to be. There wasn't even a control group of women who didn't eat chocolate. And the study found no difference in preeclampsia or high blood pressure between women who ate the two chocolates. So there is no way a study that boring can make it to television, right? Well, wait. Because that medical society issued a press release with the much sexier but pretty misleading title, The Benefits of Chocolate During Pregnancy. And because most TV producers just read press releases, this happens.
Turns out if you're pregnant, eating 30 grams a day of chocolate, that's about 2/3 of a chocolate bar, not the whole chocolate bar, could improve blood flow to the placenta and benefit the growth and development of your baby, especially in women at risk for preeclampsia or high blood pressure in pregnancy.
Except that's not what the study said. It's like a game of telephone. The substance gets distorted at every step. And I can only imagine how someone who watched that segment must have described it the next day. Oh, the news said our baby is made of chocolate and it's okay if I eat it, but only 2/3. And it
All right, so the question says, what does he mean when he says there was no control group? Well, there was no group of pregnant women who consumed no chocolate to compare to. So that's control. We want to see if there is a difference in them as well. What does the word significant mean in statistics? That the chances of observing an outcome like that just by luck or chance are so low that there must be another reason, such as the chocolate. So that's what significance